Welcome to this comprehensive guide on synchronizing player positions and scores over a network in Unity 3D, specifically tailored for beginners. Open the Player Movement script in Visual Studio. We'll start by inheriting from network behavior instead of monobehavior. We will cover the fundamental concepts of Unity networking, focusing on practical application and code demonstrations to ensure you grasp each step thoroughly. Our journey begins with preparing your Unity project for multiplayer functionality, laying the groundwork for all subsequent networking tasks. First, open Unity Hub and create a new 3D project. Name it appropriately, such as Network Sync Tutorial, and choose a suitable location. Once the project loads, navigate to the Package Manager by going to Window, Package Manager. Here, we'll install the necessary networking package. Search for netcode for game objects and install it. This package provides the core framework for building networked games in Unity. After installation, you might be prompted to restart the editor. Proceed with the restart to ensure all changes are applied correctly. Next, we'll create a simple player prefab and add the essential network components required for synchronization. In your scene, create a 3D cube game object and rename it Player. This will serve as our basic player representation. Drag the player game object from the hierarchy into your project window to create a prefab. This allows us to instantiate networked players. Now, select the player prefab in the project window. In the inspector, click Add Component and search for Network Object. Add the Network Object component to the prefab. This component is crucial for any game object that needs to exist and be synchronized across the network. Next, add the Network Transform component. This component automatically synchronizes the position, rotation, and scale of the game object. Ensure the Network Transform component is configured to synchronize position and rotation, which are essential for player movement. With our prefab ready, let's dive into scripting player movement and ensuring it's properly synchronized across all clients. Create a new C# script named Player Movement and attach it to your player prefab. Open the Player Movement script in Visual Studio. We'll start by inheriting from network behavior instead of monobehavior. This change is fundamental for accessing networking functionalities provided by netcode for game objects. Inside the update method, we need to check if the current client is the owner of this player object using his owner. Only the owner should process input and move their player, preventing other clients from controlling it. Implement basic movement logic using input.getAxis for horizontal and vertical input, then apply it to the player's transform. For example, transform.position plus equals new vector 3 asterisk move speed asterisk time dot delta time will move the player. Now, let's set up the Network Manager in Unity to handle connections and spawn our network player prefabs. In your scene, create an empty game object and name it Network Manager. Add the Network Manager component to this game object. This is the central hub for all networking operations. Drag your player prefab into the player prefab slot within the Network Manager component. Also, add the Network Manager HUD component to the Network Manager game object. This provides a simple UI for starting host, client, or server. With movement synchronized, our next step is to synchronize player scores, a common requirement in many multiplayer games. Create a new C# script named Player Score and attach it to your player prefab. Open Player Score in Visual Studio and ensure it also inherits from network behavior. We'll use a network variable, int, to synchronize the player's score. Declare public network variable, score equals new network variable int. This network variable automatically handles synchronization of the score value across all connected clients. To update the score, we need a server RPC. Create a method like server RPC public void add score server RPC. Inside this RPC, update the score value plus equals amount. Only the server can directly modify network variable values. Clients will call this RPC to request the server to update their score. For example, add score server RPC. To display the score, you can add a UI text element to your player prefab and update it in the onNetworkSpawn method or update. For instance, score.onValueChange plus equals scoreText.text equals score plus new value. We'll update the UI. Now that our player movement and score synchronization are set up, let's test our multiplayer game. Build your Unity project for Windows, Mac, or Linux. This will create a standalone executable. Run the built executable. This will be your first client. Back in the Unity editor, press the play button. This will be your second client, running as the host. In the editor's game view, click Host on the Network Manager HUD. This starts the server and a local client. In the standalone build, click Client on the Network Manager HUD. It will connect to the host running in the editor. You should now see two player characters in both the editor and the standalone build, moving independently. Test movement from both instances. Each client should only control its own player, and the other player's movement should be synchronized. Implement a simple trigger to call addScoreServerRPC when a player collects an item, observing the score update. When a player collects the item, their score should increase and be reflected on all connected clients. This demonstrates successful synchronization of both player positions via network transform and scores via network variable and server RPC. Congratulations! You've successfully set up and tested basic network synchronization for player positions and scores in Unity 3D. This foundational knowledge will enable you to build more complex multiplayer interactions and game mechanics. Remember to experiment with different network components and RPC types to expand your understanding of Unity's networking capabilities. Thank you for following along with this tutorial. We hope it provides a solid starting point for your multiplayer game development journey.